All right, good morning. It's 9 a.m. Let's fill out feedback forms until 9:05 or so. In the meantime, I'll go over what we've got for this week. Andrew Klitsky is going to be coming in today. I think this is his last week because he just got a job offer. He's been with us for 3 weeks just as a volunteer on Tuesdays from 9 to 5. Mike won't be in until 10 a.m. this morning. We're going to have career prep part 1, GitHub and public documentation. So we'll talk about like what that, two people will be coming in, one from G18 Consulting and one's from ParkWiz. These people are, people who look at resumes pretty much all day long. So they're going to be here just to kind of talk about what online presence looks like, what a good LinkedIn looks like, and then we'll start doing all of that kind of stuff tomorrow. We're going to spend a good chunk of the morning just kind of learning of what's a good LinkedIn, how do we get things off the ground, et cetera, et cetera. For those who are asking, when's the AMTA? We only have an AMTA on Wednesdays from 7 to 9 a.m. So that's going to be tomorrow. Matt will be available remotely. I believe you can just go on Slack and just look up Matt Goggin, and then his information is going to come up. I'm going to be talking about diversity and inclusion tomorrow from 2 to 3. And then Thursday, we'll have a person coming to present on Git from 10 a.m. to 12 p.m. So I'll kind of give you a few more minutes to finish up, and then I'm going to go over kind of apple trees. I see some help wanted here, so we can do maybe we can go over it together and see like what's best practices, what's missing, and things like that. You all got to, you all have met Darnell in the past, but how was his little thing at 5? Good. Yeah. His haircut reminded me a lot of your haircut.
Oh, he was wearing a hat the whole time.
Oh, he was wearing a hat the whole time.
Okay. Put more hands. Yeah.
So after lecture, are we just free for challenges and then the career prep?
Yeah, just be back by 5:30.
Because I'm just trying to figure out when to reschedule my mentor, because she was supposed to come in at 5.
She was supposed to come in at 5 o'clock.
Yeah, maybe probably. I don't know if I should say 6:30 or after 6:30 or before 5.
You can, either one of those will work.
Okay.
Yeah, before 5 might be better. Our last minute, and we'll get started for today. Okay. All right. So yesterday's, like most of the challenge, like we've shrunk down considerably just on the number of challenges we've had so far. So we went from 6 down to 2, but those 2 take a lot longer, as you can kind of see. And pretty soon in like a few weeks, it's just going to be like one challenge for the whole day, because that one challenge is just consists of so many different parts. Yesterday, did anyone get to bowling, or was it just apple trees the whole time?
Me and Leanna got to.
Okay. Let's kind of just review apple tree. This one's not terribly. This is not algorithmic in any way. The challenge for apple trees was just basically, how do I model using object orientation? How do I model out all of this stuff? Fun little fact. I didn't know this, but 125 million boxes of apples per year. That's 2.5 million tons of apples. It's a lot of apples. I kind of want to do a quick poll and kind of get an idea of what's everyone's favorite apples. Not because I particularly care, I'm just curious. Not that I'm going to buy any apples for people based on your preferences, but I'm just like wondering what your favorite apple is.
Green.
Green apple? God, okay. Okay.
Pink lady.
Pink lady?
Fuji.
Fuji? Okay. Mine's also Fuji. What about who's calling on remote? Leanna, what's your favorite? What's your favorite?
Gala.
Gala? Okay. Kimberly, is there like Italian apples or anything like that?
Well, yeah, but my favorite apple is the Jazz.
Jazz apple. Okay. Very cool. I think Honeycrisp is overrated personally. The green apple. Yeah, this is interesting. I don't know if I could teach you anymore. All right, so I'm going to open up a few things. One page is just going to be for Chrome. One page will be for iTerm. And one page will be for Sublime. Let's bring down Kimberly's branch. And again, the way that I do this is I'm going to first clone it down, downloading it from the internet, bringing it onto my computer. Everything in Sublime. Now, if you can see right now, if I go inside of Apple Tree, there's not much in there. This is all like the old stuff that we've seen from before. But the moment I check out to her branch, so git checkout Kimberly's RB branch. I'm no longer on my branches, on the master branch, as you can see, but I've actually moved over entirely to Kimberly's Ruby branch. You can kind of see this is all the stuff that that's here. All right, so let's take a look at what we've got. Release 0. So we have different releases just to kind of guide you as you go along. First things first, so let's implement the Apple tree and the Apple class. We're going to use adder, reader, writer, and accessor, so you can call it tree height and tree age. Which one of these three methods should you be using and why? So we have a choice between adder reader, adder writer, and adder accessor. Let's take a look at what we've got here. So Kimberly decided to choose adder accessor and for adder accessor for the age and height. Why did you choose to do that?
I did that because we're going to be changing the age and the height. We're going to be adding years and adding height.
Mm-hmm. That's pretty much it. When you first plant a tree into the ground, it's a fixed age and it's a fixed height. But as time goes on, that tree is going to eventually get larger and larger and larger until a point that it just dies because it's too old. So I believe, let's take a look at the Apple tree spec. This looks pretty decent. Apple tree, I expect the age of the tree to be 0. So when I create a new tree, the age is going to be equal to 0. I expect the height of the tree to be 0 when it's first good. So I think these first two look pretty good. Second. Right. So all right, so we see that we're using adder accessor because the age and height is something we both want to read and something we want to write to. So that makes sense. When she first creates a tree, the age is going to be 0 and the height's going to be 0. So we're just saying it's just a small little seed just to begin with. Do the same thing with the apple class so that we can call apple.diameter to get an apple's diameter. Okay, so I believe these tests to be completely correct. So describe, it's going to be hashtag age and hashtag height because these are both methods. And it expects the age of the tree to be 0 when it's first planted. So this let tree on line 4 is basically the fancy way of creating a variable like tree equals apple tree new. Now you could do two things. One of them is inside of every it block, you can just create a new tree like this. And then you have a local variable called tree between the it and the end on line 15 through 18 and on line 8 through 11. So tree is just going to be available in its immediate scope right here. But that kind of sucks because I'm using the same tree over and over again. Why do I want to create multiple things? That's line 4 right here. Line 4 is basically this let tree, and then in parentheses, appletree.new. This is the syntax. This is the same thing as doing this in every single describe block. By putting it at the very top here, it's available in this describe block, this describe block, this describe block, so on and so forth. It's just a shorthand for this.
So if you did the not shorthand up top, would that suffice?
It would not suffice. Yeah.
Okay.
The way that our spec runs, like, question was, can I replace line 4 with this? And the answer is no. Our spec specifically requires you to create variables like this if you want to reuse it in different blocks underneath. So I agree with the I agree with these tests. They're well written. You know, I have the hashtag for which method are you calling. It expects the height of the tree to be 0 feet tall. That makes sense. When I create a new tree, the height and the age should be equal to 0. So I believe these two to be correct as of right now. So we're going to do the same thing with the apple class so that we can call apple.diameter and get an apple's diameter. So it looks like that's what Kimberly did. At the very bottom, I have a class apple, and this is just add a reader for diameter. You can't change an apple's diameter. Like, you're not gonna, well, I guess you could. You could just wait. Like, I guess you could, but like, more or less, the idea here is just like, I'm just gonna be reading the diameter. I'm not gonna like overwrite. I'm not gonna walk up to the apple and say your diameter is now like 5 feet wide, and I have an enormous apple. That's not something that can happen. So that one's fine. So I believe all of these work. Release 1. As a tree ages, it grows taller, and eventually it starts bearing fruit and stops growing. Not necessarily at the same time. Some years later, the tree dies and can bear fruit no more. So we're going to implement a tree age instance method that will age your tree 1 year. Every year, the tree gets some amount taller and then eventually stops growing, and you can decide that. So it's kind of like, in terms of real life, if you try to imagine object orientation in real life, you have a kid, right? They're 3 or 4 years old. Each year, let's say you have a 5-year-old, they're right in front of you, and ask them, how old are you? And they're going to say, I'm 5. How tall are you? And it's 3 feet. I don't know how tall 5-year-olds are. Let's say that they're 3 feet tall. So they can, at that particular point in time, I can ask you, what's your height and how old are you? As they grow older, you know, each year that they grow, they're going to grow a little bit, a little bit, a little bit until they reach like teenage years or so. And then they're just going to start growing like 6 to 8 inches in a year for a set period of time, maybe until they're 18 or 20 years old, and then they stop growing. But that's always going to be the case. Your age will grow, and then at one point your height will stop growing. I was really sad because I was like just an inch short of 6 feet. So had I only started growing a year later, I might have been okay. I'm not sure that's really how it works, but we're going to do that over here on the age method. So let's take a look at the specs we have for the age method. So the age method should age the tree's age by 1. So when I do tree.getAge to change tree age from 0 to 1. Okay. And it should increase the tree's height. Tree.getHeight. So I guess I probably wouldn't have a age and like a get age and get height method. I guess I'm not sure, Kimberly, what you were trying to go for right here.
No, I was just trying to get tests to pass. Actually, in this next iteration, I combined all those just in the age exclamation point method.
Yep.
But I got so frustrated with our spec that this is just kind of the way it ended at the end of this release here, this release 1.
Sure. So again, the idea behind the age method is that every single year that you call age on it, it's going to grow. It's going to get 1 year older, and it's going to get just some little bit taller. So let's say, let's change a few things. I'm going to get rid of this. I'm going to get rid of this as well. All right, so it should age the tree's age by 1. So if I were just to call let's say like current age equals tree.age. And if I do, let's just do this. So expect tree.age. So let's kind of read through what I've got here. I have a tree that we've created on line 4. I'm just going to get the current age from it. And I know that we have that age method because we wrote the specs for it on line 6. I'm going to call tree.age with a bang on it. And then this magically will increase their age. So I have a current age that's equal to the age before I aged the tree. And then I'm going to call new age, which is the age of the tree after I've aged it. So my expectation is that the new age, this one on line 22, is going to equal the current age plus 1. That's my test to basically say like, hey, I've increased the age of this by 1 year. So I'm going to just run line 19 specifically. I don't want to run everything else. I just want to run line 19. And the way that I do that, list everything out, I'm going to run, why are all these with stars on them? Don't know. We'll find out. We'll do rspec, apple tree spec, and I'm just going to add a colon and add for line 19. Colon 19, and I'll go back to it in just a second, says find the spec at line 19 and just run that one particular spec. You can do it on this line. You can do it right in the middle of the block. It's smart enough to know. But if you do like line 25, it doesn't know what to do, so it'll run everything. But if you do any number between 19 and 24, it'll know how to run that particular spec. Let's take a look. All right, so it looks like it's a green spec because the code's already written for us. Are there any questions on like how I wrote this spec here? Because basically, I took the age, like when it was first born, I aged the tree, I took the age afterwards, and I expected it just to differ by 1 because it's supposed to increase by 1 year.
So you can target your instance variables?
Yep.
I know you can target your methods. Okay.
Yep. So the instance variables, when you add the adder accessor, it turns your instance variables into methods.
Okay.
Yeah.
That makes sense now.
Mm-hmm.
So age.bang ages the tree?
He was first. He was first.
Go ahead, Trevor.
No, you're good.
All right. For the R spec, any it block, we don't, as long as we do that let, if we do that let at the top there, in terms of initialization of the class, we don't have to initialize in the it block anymore.
Correct. Yeah. So we covered this a little bit earlier, but this is the equivalent of typing tree equals apple tree.new in every single it block, but you're repeating yourself a billion times. It's kind of annoying. So you just want line 4. Line 4 will take care of all of that for you.
Appreciate that.
All right, so let's, so we have current age equals tree.age. I'm going to age the tree, the new age, I'm going to grab it, and that difference should just be 1. So let's fix this up a little bit. So age, I think all we have to do is just do at age plus equals 1. And we'll just do that for now. I think that's about it that we need to figure out. So let's run the text one more time. It still passes. We're good to go. Again, this is the power behind test-driven development. We have the tests. We know we're 100% covered, and then we can move on to the next thing. All right, this next one, it says it should increase the tree's height. So using that same line of logic, I will just run current height equals tree.height. I'm going to age the tree. I'm going to take a look at the new height. So I expect the new height to equal the current height plus 1, or old height, I suppose. We're going to run this. And I'm still running line 19, so that's why it's passing. I'm going to run just line 26. I'm not going to choose line 26. I'm just going to choose line 29. So I'm just choosing a random line in between 26 and 31, 29 instead of 19. bam, I got an issue right here. It says that I expected 1 and I got 0. So I wrote the test, it failed. It's red. Now I'm going to make it green. I'm just going to do @height plus equals, I'll just choose a random number between 1 and 5. Sure. We'll just go with 1 and 5. That's going to be an issue with this one. We'll just do height plus y plus 2. And the specs again. Now it's a passing spec.
What's confusing is the age and the age exclamation mark.
So these are two different methods. So this adder accessor for age looks like this. The adder accessor of age is shorthand for these 3 lines of code. It turns your instance variables into methods so you can call them directly on there. So there's an age that returns a there's an age that returns like the number of your actual age, and then there's an age with a bang on it, which basically says you're going to get older. So as of right now, like there's better ways to write this RSpec code, but I'm just going to keep it like this for right now, just so it's a little bit easier to read. And as we get more comfortable with RSpec, then I'll get a little bit more fancy with these. I believe Kimberly had like curly braces and things like that instead of parentheses here. If you want to know what it is, it's basically instead of evaluating what's happening here, she can actually call tree.age directly inside the curly braces. It's like instead of evaluating some like attribute, I'm actually going to call a verb. It's like instead of seeing what the adjective is, I'm going to call a verb directly. But I don't want people to get confused with that. I'm just going to do simple RSpec right now. Now, if you take a look inside of this this apple tree thing, it says that every year the tree should go some amount taller and until it stops growing at one point. So you have to choose for me, like, what age do you want to say that? What age do you want for it to stop growing? How long do apple trees live? Would you guess?
I looked it up. It says up to 100 years.
100 years. When do you think it's? That's crazy. I'm pretty sure it stops bearing fruit at one point and it just becomes a tree. But like, when do you think the tree stops growing if it's 100 years long?
Well, it grows 6 to 10 inches a year. So what, in 10 or 15 years, it's at maturity level or height?
Okay. That's fair. What we can do then is we can add a little bit of a condition that says, like, each year the tree is going to grow some amount taller and then it's eventually going to stop growing. And we can decide when that tree stops growing. So we'll just say if age is less than 15, then we're going to add some sort of height to it. That makes sense? Like, basically, I'm going to continue aging it if it's less than 15 years old. So if it's more than 15 years old, this height will stop growing. So every single tree, it looks like it's going to be 30 feet tall, which is that really tall for a tree? 30 feet? I don't know.
They're between 25 and 30 feet tall.
Oh, perfect. Look at that. We did it perfectly. All right. And then later it should die. At one point, so let's just say we should probably add a spec that basically says it's something due and then end. So it ages until 15 years old. It grows until 15 years old. So what I'll do is I will say, it looks like we know that if it's going to grow by 2 every single year, then it's going to be 30 feet tall in the end, right? So if I just do 15 times do tree.age, I'm going to expect the tree.height to equal 30. Well, actually, let's just age it 16 times. How's that? Actually, we can age it 20 times. It doesn't even matter. But we expect when we age it 20 times that it's only going to grow up until the 15th year. let's just see if this works. So the spec I'm worried about is line, let's just choose 35 because it's within this it block right here. And it passes. So even though I've aged it 20 times, like the height only grows up to 30 because I'm only aging it, I'm only letting it grow until it hits age 15.
In Bash, could you have just called line 37 after the end statement?
Sure. Yeah. As long as it's the range of the number is between 33 and 38, you're good to go.
Okay.
So I can choose 37. I can choose 38. I cannot choose 39. Actually, can I choose 39? Oh, it's because it's in here. If I cannot choose 40. I don't know what's going on. Just choose a number between this range here to be absolutely certain.
Can you explain again why, with your adder accessor, when it can read and write, why you still have to use the add symbol in the aged bang method?
Yeah, sure. So the question was, like, I thought if I had an adder accessor, I could just do like, why do I have to, can't I just do age plus equals and then height plus equals? Let's run it and we'll find out. So we'll just run line 38, like we said before. We get a false. So if we take a look, it says there's an undefined method plus for nil class, specifically in line 14. So the way that I read this is, first things first, like I know there's a lot of different things that are wrong, but the one it actually blows up on, the line it blows up on is actually the top line right here. So it's line 14 in appletree.rb, and I'm looking for plus. And because you can't add something onto a nil. So I go to Appletree, line 14, and a plus. There's my plus sign, which means I can't, that means that age is nil at this point. So I had to learn this yesterday. You have to, in order to add something to an instance variable, you do have to add the instance in front, the @ symbol in the front, and you can't do the, you can't just do this. And the reason behind that is that the adder, so adder reader for age looks like this. Just a method that says age that returns the instance variable. The adder writer actually looks like this. So you can't add onto a method because as of right now, like age is actually just a method and you can't add onto a method.
But you can reset.
You can
set a new assignment.
You can, yes, you can assign a new one to it.
Okay.
But there's a way that you have to specifically call it. You have to do like tree.age equals new age.
Okay.
So in order to alter an instance variable within the class, you have to throw the @ in the front.
This is kind of like on and off, but what's the difference? What would be the difference between tree and self?
So the question was, what's the difference between tree and self? So as of right now,
we don't have to go over it right now.
Yeah. So basically, the quick answer is everything we're dealing with right now is an instance of it. If we're dealing with a class, you throw a self in the front, like self.age. It says like you're going to age every single, like you're altering it at two different levels. One's at the instance level and one's at the class level. That's the simplest way I could say it. But I don't want you to worry about it right now because right now we're just dealing about just instances and not worrying about actual classes. Let's see how far we've gone. Okay, so we have a height. We have an age that returns the current age. We have an age with a bang that ages the tree 1 year, grows the tree if it's able to grow. And we need to have this method that says dead to basically return true if the tree has died. So it looks like I need to have a tree. I don't need 2 tests. Probably 1 is enough. I have a hashtag dead question mark, and it should kill the tree eventually. And I'm going to get rid of this for now so that we can rewrite it together. So I don't need this get height. I don't need this get age. And I just need to know if something is dead. So there's a method called dead. I'm not going to write the code yet because I want to do test-driven development. So basically, I'm going to let's just, how long do you want the lifespan of a tree to be? 200 years. Or I think Kimberly said it was 100 years. It's yesterday. So let's just do.
Yeah, I was playing around with 100 years.
Okay. So we're gonna say expect let's age a tree 50 years. 50 times do tree.age. Expect tree.dead to equal false. It should, and my test will be like, it should be alive if it has not hit the death age. All right, so I'll write that test first, and then I will write another test for it should be dead if it has hit the death age. We'll say maybe 150 times do tree.age, and I expect the tree to be dead by that point. I'm going to run the tests.
You're also on the left side, on line 16, you're missing an at. 16.
Thanks. I want to run both the tests in this describe block. So if I were to choose just like line 43, it would just immediately go to the scope of this test right here. I want to run both of them, so I'm just going to run line 41. I have 2 examples. I have 2 failures. That looks good because I haven't actually done the code yet. So we said we want the lifespan to be 100 years. Let's just say that. So I'm going to throw that in the initialize, because whenever I plant a new tree, every single tree knows I have X amount of time to live. Similarly, if every single human being, we know that we have at most 100-ish years, right? We're not going to live to 200. We're not like that doesn't happen. We know our lifespan is very limited. So our lifespan, let's say that apple tree is like us. It has a lifespan of 100. I'm going to make that an adder reader, writer, or an accessor. What do you think?
Reader.
Reader. Why is that? It's not going to change. The lifespan of the average lifespan of an apple tree is 100 years as of right now. We can probably do some technological advances on apple trees and make it live longer, but for now, we'll just deal with the lifespan being 100. So basically, I'm going to say like if age is less than lifespan, we're going to return false because it's not dead, right? And otherwise, true. This is look to people. If your current age is less than lifespan, then you are alive. Like if I'm 27. So if I'm less than 100, which is when most people die, I'm still alive. Otherwise, I am dead.
And here we don't need the add sign because we're not modifying.
We're not modifying it at all. Yeah, and since we have an adder accessor, we're calling a method called age, which is basically just returning the instance variable. Just one more time.
Where's the age method?
Right here.
That's age with a bang.
Age with a bang. So age is just the since we have it as an adder accessor, it just reads the instance variable.
Right.
So let's run this test right here, line 41. All right, so we read, and then we turned to green. We made it pass. Now we're going to refactor this. I don't mind these if-else things. It's very, very clear, but I'm going to refactor this into one line. That's it. This is going to return true or false. Is the age less than the lifespan? So let's go back over here. On the specs, everything is broken. Undefined method plus on line 16. Did I mess something up? Let's see. All right. It should be alive. It hasn't hit at death age. I'm going to call age bang. There's undefined method on line 16 for age. Line 16 for age plus equals 1.
Oh, there's an F on line 10.
F on line 10. Oh, good call. Typo. That would have driven me insane for a long time. All right. Just run the specs. Still getting true and false. All right. So true and false. So I have these backwards. Something is wrong here.
Oh yeah.
It's just that. Let's find out. Is that okay? So basically, before I had an if check that basically says if the age is less than the lifespan. Basically, and I narrowed it down to one line. Basically, if something is dead, then your current age is larger than the lifespan. So if it was like 5 and the lifespan was 100, like this value is false because 5 is not greater than 100. But if you had 105, 105 is greater than the lifespan, which is 100. So I can continue to go through this if you'd like. I don't know if that would be of some value. It's up to you. Or if you want to jump into today's new topic.
It's all useful.
It's all useful. I have one vote for each. I'll see more, and
Gerald will see more.
we'll see more. Okay. Well, we'll continue to go on and see more things. For right now, I'm going to run to the restroom. We'll take a quick break, and then we'll get back to it.